Hello and welcome back to the second video in our series on the topic of solids in contact. So in this video we're going to look at how to locate the plan and elevation positions of a point that's going to be on the surface of our various solids. So to start with, we're going to take the example here of a sphere which has a point on its surface. So looking at our object, we can see we have our 3D view over here, we have our 2D view over here, and from the 3D view we can see that the point that we're starting off with is located on the extreme generator of the object when looking in from the front. So if you remember from our last video, the extreme generator is this rim here that separates the part that would be in light and the part that would be in shade, and that edge there becomes the outline for our front elevation. So when looking in from the front, we can also see that that outline for our front elevation would be located on a line going through the center in our plan view, like so. So that's what we have here with our 2D view. So we can see our point is located on the extreme generator in our plan view, and we know that when looking in from the front, looking in perpendicular to it, that's going to be on the edge of the object in our elevation up here. So to locate our point, all we need to do is just simply project our line up into our elevation, and it's going to be on the edge of the object. Now it can be on the top here or it can be on the bottom, so we have a choice here. If we look at our 3D view, we can see that it's located on the top, so that's going to give us the position of our point, like so. If we weren't told the position of the point, it could be in either position, but generally speaking we're told whether the rough position it's going to be in. So that's what to do if the point is on the edge when looking in from the front. In our next example, we have a similar enough case, only this time when looking from above, the extreme generator is the line. So the top is in light here, the bottom is in shade. So it's on our extreme generator in our elevation. So because it's on our extreme generator in elevation, we know it's going to be on the edge in plan this time. So like before, all we do is we project down into our plan this time, and it's going to be on the edge of the object. So it can either be the front, it can be the back, and again, like before, looking at our 3D view, we can see it's located towards the front, so that's going to give us the position in our plan view here. So that's what to do when we're dealing with, say, a sphere, say two possible situations with our sphere. For our next example, we're going to look at a cone. So same principle applies. This time we're given the point in our plan view, and we can see it's located on our line going perpendicular to our viewing direction, running across from the center point. So it's going to be on the extreme generator, which means it's going to be on the edge when we project it up into our elevation. So projecting it straight up into our elevation, that's going to be the position of it when it's on the edge in our front elevation. So exactly as what we do with our sphere. So in each of those examples, we've seen that the point has been located on the extreme generator. Now, we'd be very fortunate if that was the case in every question. Unfortunately, that isn't always the case. And sometimes we'll get a situation where we have the point located not on our extreme generator nor on the edge, so somewhere in between. So it's on the surface of the object, but it's not on the extreme generator or it's not on the edge. So how do we go about finding it? Well, we don't have a simple way to do it like we had before. We can't just project it straight to review. We have to go through one extra step, and the extra step that we have to go through to locate it is to move the point around so that we are seeing it on the extreme generator first. So in order to do that, what we're going to do is we're going to take our point, and using the center of our object, we're just going to roll it around so that it's on the extreme generator here. So rolling it around like that, and we're just temporarily moving it into a side position. So it's on the extreme generator, and now we can locate it on the edge in our front elevation. And what we're doing here essentially is, it's like cracking an egg. If you imagine your egg in the morning and you top off the top of it like so, well, there's the crack, or the topping of the egg there is a horizontal line, so a level line, and when we look from above we get this circular shape. So that's where this arc is coming from, and that's exactly what we have here. There's the egg topped like that, and like running around the rim of the shell, there's our point travelling along so that it's now in the side position, and as it travels it doesn't lose any height. So that's one way you can imagine it. Another way you can imagine it is if you just grab the sphere from the very top there, and like a football, if you just roll it around, so spin the sphere around, and as you spin it around, the point just rolls around like that. Because you're just rolling it around, it doesn't lose any height, it just travels in that circular pattern like that. So when we have it in the side position, we're able to locate it in our elevation. So we bring it up, and we have it now located in our side position in our elevation. Now, that isn't the original position that we were given it in, so what we need to do now is we need to take it from our side position and we need to roll it back again, like so. So by rolling it back, we're going to, we already have its proper position in our plan view, so we can just mimic that by going a level line going across. That's as if we were rolling it backwards again, taking our point up from our final position in our plan view, locating it in elevation. So that's the position elevation, and that's the same as rolling it around and back like that. So you can see, just let's do that again. We can see we're, by rolling it around here, it's just traveling straight across like so. So by rolling it around here, it's just traveling straight across. So it's this line here represents this arc. So one in plan view, one in elevation. So there's our movement there. So we can see we found the final position, or our original position. So we've moved it temporarily over to the side, and then we move it back into our correct position. So there it is, temporarily on the side, and then moving back to our final position. And that's a common strategy that we do in Saws and Contact. It's probably the most common strategy that we're going to do. Generally speaking, we say that we solve the object initially in its side position, and then we move it around into its final position afterwards. So that's what we're after doing with the likes of our sphere. You can see the exact same thing applies then with a cone. So like before, we have our point here located somewhere inside the object. So it's not on the extreme generator, so it won't appear on the edge. It's going to appear somewhere inside the object like that. Now we have two strategies for this. The first is exactly like what we did before. We just roll it around like so into its side position. So because it's on the extreme generator here, we know when we project it up, it's going to be in the edge or the outline. So then we roll it back into our position, and you can see there's our final position, or our original position. So what we've done with our sphere holds true for the likes of our cone as well. There is a second method that we can use with our cone, and just with our cone, but because our cone is generated by a series of straight lines, so if you can imagine a straight line being spun around, there's any number of positions for our generators here, our straight line generators, and our second method is just simply to draw in a temporary generator. So from our center point of our cone, we draw a generator through the point that we're trying to find in our elevation. So here it is in 3D, through the point, and where it crosses the base, well, we know that the base is going to be on the ground. So if I just project that up, we can see we've located the point for our generator in our front elevation. So there is our generator now drawn in. So it's our temporary generator. And we know that the point here is on the generator. So when we project it up, where it crosses the generator is going to give us the position. So there's our point located. So that's a second way. It's a very quick way to locate your point. But either way works perfectly well. So whether you're rotating it around, as method 1 showed, or whether you're using your temporary generator, both methods perfectly fine. The last example we're going to look at here is of a cylinder. So a cylinder is a little bit of an exception insofar as that because our cylinder here isn't like spherical like the likes of our sphere, or isn't tapering in towards the front, any object that's located, say inside here like that, is always going to be on the edge. So every point that we have on the outer surface of our cylinder is automatically going to be located on the edge here. So to deal with that, we just take our point, project it down, and that's it located in our plan view. So you don't need to worry about rotating things around. You don't need to worry about putting in generators. If it's on the outer surface of our cylinder, it's going to be on the edge in our plan view. So we can see there's our line just projected down. All I've done was taken it back along my plan view and then projected it straight up. So that gives us the position. So down, across, and that gives us the position in our plan view. So there are three common examples that you're going to see throughout the topic. So again, hopefully a little bit of an understanding of what's going on will help kind of ease your solution of problems or solving of the problems. I say when you know what's going on, it does make it a little bit easier. So as always, I hope this has been of some help to you, and stay tuned to the rest of the videos. So thank you very much.